thank you everyone for coming. Welcome. And taking your Saturday morning to come and learn a little bit more about math and the Halton District School Board. My name is Melanie Gonsalves, and I'm a teacher, and this year I am a math coach in our board, which is a wonderful opportunity to travel to different schools and experience math across our board, and there are really exciting things happening. Today we're here to talk a little bit about number talks, what they are, what they look like in the classroom, and have some participation from the audience. So I'm really looking forward to that. If you attended the keynote speech this morning from Terry Blackwell, I know she touched on a lot of that, and we'll go in a little deeper to talk about what that looks like in our classroom. Okay? Awesome. So we're going to start with a junior focus, because we know a lot of the times when we talk about our junior student, we think multiplication, and we really, really want them to know our facts. And as adults in particular, we're starting to see that there's something a little bit different happening from the way we learned our facts to the way we're kind of encouraging kids to look at math, think about math, and learn their facts. Mental math is part of our curriculum. It is in there. But I think more importantly, it's a life skill that our kids need. So we do want kids to know their facts. We want them to know them, though, so that they're more intuitive. When we think about memorizing a fact, kids kind of learn them in isolation, and they may not have that ability to apply that knowledge to another situation. So through our number talks, we're really encouraging kids to dig a little bit deeper into how they understand numbers, to manipulate them in different ways, how to put them together, how to pull them apart, so that they really know that fact, and then they can apply it to other situations. Should there be something they don't know, they're not stuck. They have other strategies that they can use to help them out. Okay, so here we go. Can everybody give me a little thumbs up, kids in particular, if you have done a number talk? If you can tell me what a number talk is. What do you think a number talk is? Mm-hmm. Yes? Oh my goodness. Okay. Wonderful. Does anybody have anything? Thank you so much. Does anybody have anything they want to add on to that? Anything else that we know about a number talk? You just said it so very, very well. So we're going to put some numbers or a question up on the board. Oh my goodness, I know. It's very exciting to talk about this. So we're going to put some numbers and a question up on the board, and everybody has a job in a number talk, right? Everybody's job is to think. That's our job when we go to school. That's our job when we're adults. We need to think. So when we think, you said it perfectly, we're thinking. Okay, and this just means I'm thinking, I'm trying to figure out what the answer is. I just don't have it yet, but I'm still going to keep thinking, right? That's our job. Wonderful. So you must have read my mind. I had this all set for you up here. So think about, how could you answer the question? And then what did you say I do when I have an answer? Okay, so I'm ready with an answer, right? Okay, so when I have an answer, I put my thumb up. Okay. My goodness. So I have my thumb up, and it's quiet. Why is it quiet? You know, a lot of times in class, we like to hear kids talking, we like to hear the thinking, and then when we know the answer, we throw our hand up in the air. Why are we having just a quiet thumb instead? That's right. So other people who don't have the answer yet can still keep thinking. If you're like me, I need a little bit more time to think. And math is not a race, right? We want to think about how to get the answer. It's not always about being the fastest, right? So we're quiet and we're waiting. Now, if we're waiting, could we be doing something else? No, we're not going to do anything. We're not going to get up and walk around, are we? No. But what else could we do? So we could think of a different way to solve the same question, get the answer a different way. Fantastic. And I know some teachers use some other symbols, right, in class. And so if I'm called upon to share, I'm going to explain my thinking. right? Okay. So we are going to share our ideas. And one of the nicest things about this is we get to learn from each other. Even as a teacher, I learn so much from students. They come up with things I have never thought about. And I've thought about this in advance. I plan it out and I say, here's what I think they'll do, and they still come up with more. It's amazing. What's our other job? So I've done my job. I thought, I got the answer, I shared my thinking. Is that it? Are we done? Our other job is to listen to other people, okay? They might not have got the answer the same way we did. So we want to hear what they have to say because we can learn from each other, okay? And the last thing, and I love that you use that word strategy, is to try new strategies. We want to think, could I try something new the next time? Did somebody share a strategy that I thought was really neat that I hadn't thought of before? Okay? And that's our job, to try to push our thinking and try new things. Okay? Give me a thumbs up. Is everybody good? All right, audience participation time. Adults, feel free to join in, but I leave it to you. Kids, are you ready? Okay, good stuff. All right, so boys and girls, we're going to talk about multiplication today. It is one of those things that these facts are important to learn, but we're going to dig in a little bit deeper and see what are those strategies we use when we multiply. So everybody's ready to think? Marvelous. This board is very high and I am not very tall, but I will try my best. Marvelous. So quick silent thumbs up when you know the answer. 2 multiplied by 6. Give people a little bit of time to think. We could also think of it as 2 groups of 6. What is 2 groups of 6? 2 multiplied by 6. What's your answer? 12? Wonderful. You want to share with me how you know it was 12? You added 6 plus 6. Wow. I'm going to go green. Wonderful. So you said 6 and another 6. And 6 plus 6 was 12. Did anybody get the answer a different way? How did you do it? You counted by 2s 6 times. So can you tell me what you said when you counted by 2s? Wonderful. 2, 4, 6, 8, 10, 12. And you counted by 2 each time. So we have here 2 groups of 6, and here we have 6 groups of 2. Wow. Are we allowed to do that? Can we switch those numbers around when we multiply? Wonderful. Okay, next one. Everybody ready? Thinking thumb again. See what we can come up with. We're going to try 5 multiplied by 6. 5 multiplied by 6. 5 groups. 6. Good thinking going on in here. I can see it happening. Oh, some people might have it more than one way. What did you get? 30. Okay. Anybody have something different? Not 30? How did you know it was 30? Oh, okay. Okay, so let me see if I've got that. You said you know that 5 groups of 5 was 25, and then you added one more group of 5, so you knew it was 30. Does anybody know what I've drawn here, why I've shown it this way? What this kind of diagram representation picture is called? Yeah, very close. Thank you so much. An array. Yes, wonderful. Do you know, if you had to tell somebody what an array is, how would you describe it? Anybody know the definition? An array organizes objects in equal rows. So you're thinking that there are 5 rows with 5 objects in each. But instead of counting them, you just knew they were there, right? So we call this an open array. We don't have to count all these little squares inside when we know they're there. Well, that was a very interesting strategy that just came up there. Does anybody know, did anybody get the answer of 30 a different way? Anybody do anything different? Oh, okay, let me think about that. So you said, you know that 10 times 6 was, this whole thing is 60. So I have 10 rows of 6 is 60, and then what did you do with it?
Well, I know half of 10 is 5,
so I had, so if 10 times 6 is 60, 5 times 6 is 30. Half of it. Wonderful. Okay, moving on. Let's see what we can do here. 7 multiplied by 6. 7 multiplied by 6. We've got a lot of strategies happening on our board right now. Maybe something up there that can help us if we need it. I've seen some light bulbs going on with our thumbs when they're popping up. Wonderful. What do you think? 42. Everybody agree? We think it's 42? Let's see. How did you get 42? You just knew it. For you, that's a known fact. Okay, so something that just pops into your head, 7 multiplied by 6 is just 42. And that's what we're looking for. We're looking for using what we know to build what we call that automatic recall of fact. A little bit different from memorization. He knows what it means. All right, anybody know that it was 42 a different way? Well, wonderful. Which one of these did you use first? The two. So you said, you thought, well, if 2 multiplied by 6 was 12, and then you saw, oh, 2 plus 5 is 7. Oh, pardon me. This is 7. So 2 multiplied by 6 was 12. 5 multiplied by 6 was 30. And when I add them together, 7 multiplied by 6 gives me 42. Ooh, wonderful. Any other ways we think we can use here? No? Okay. So one of the things, I'm just going to press pause on our number talk. So this is what we call a string. Sometimes our number talks are just one question that we'll work through to elicit a bunch of different strategies, way kids can answer the question. This is a string, and it actually builds on itself to show just that we can use facts we know to help us with other facts. Can anybody name any of the strategies that we have on the board? Because we've got a few things happening here. If you had to name something, what would you call it? What do you think? Okay, so, you've named a model that I've shown a strategy on, definitely. So we have skip counting over here, and we show that on what we call an open number line. Does anybody think about what the nice thing about an open number line is? Just to give you a reference, this is a closed number line. 0, 1, 2, 3, 4, 5, 6, 7. What is the benefit of this one instead of this one?
With the closed number line, you have a sort of counting one-by-one relationship, but on an open number line, you have more flexibility with the groupings. So with the two examples we have on the board, we have groupings of 6 at the top there, and then we have groupings of 2.
Right. So here we're really counting by ones, and here we're seeing kids make jumps to bigger groups. And they're able just to represent that on the number line. We know other numbers exist in between, but we don't have to show them because we're dealing with our equal groups. So we've got skip counting. And this one over here that we shared, this just popped into your head, right? You just knew it. So it's just a known fact. What might we call these ones over here, do we think? Yeah, what do you think? Yeah, we use those arrays to show our thinking. And here we use the array to show one whole fact. But what did we do with the facts over here? Is it one whole array? It's broken into different what? Different numbers, different pieces, different parts. Does anybody know what the answer is called when we multiply? Multiply two numbers together, we get an answer. But what's the special name for an answer when we multiply? It also starts with the P. There's so many P's today. P's for parts, pieces. It's a product. So over here, we call this a partial product. We multiplied this part, and then we put them together. Okay. And we used, thank you so much for naming it, the array for that. That's wonderful. So we know that we can break numbers apart in many different ways and put them back together. Okay? So what I'd like, and we do a lot as teachers in the classroom to really get thinking going. So parents, I'm going to give you just a little bookmark, if you'd like it. And on it are some sentence stems that you can use just to really encourage that communication at home. Okay? So if you don't mind, some of the things that we really encourage to get things communicating and to get kids thinking is to ask them some questions. And not just those yes or no questions, but questions that really allow them to think about their own thinking, about their strategies, and then try to communicate them. So I'm going to give you one more question. And if I could, I'm going to get you to turn and talk to your child, should you have one here with you today, and see if we can practice some of those talk moves to understand their thinking a little more. Okay? So let's see. I'm going to just scooch this guy over here. And I want to see what you think you might do to solve this question. 7 multiplied by 12. I'm going to give you at least a minute and 3 seconds to turn and talk to your family. You came by yourself, no children today?
Well, you know, I guess when I signed up, I didn't know that it was with children. But my children have other activities now anyway, so yeah.
Sure, that's okay. What grade are they in?
3 and 6.
3 and 6. So even number talks, we're starting in grade 1, and multiplication really starts in grade 3. So these are some basic facts in grade 3 to 7 times 7. So these are kind of some things, what do you think? So we want them to know, we want them to remember, but to encourage them that if they don't know, they have other things that they can do to help them figure it out. What do you think? Do you like this?
Yeah, that's amazing because, when I learned, it was more memorizing.
Right.
Okay, you have to memorize this timetable and then you're fine.
And you were timed too, and it was so separate from everything else, where now we see kids who learn this way, they're applying it to so many other things, and they're so much more confident, right? It's wonderful. Okay, have we had some good conversations? I gave you a minute, 7 seconds. It was a little bit more than I said. But I think what I've learned as a teacher and what I like so much is I learn so much by listening to what the kids have to say. And it really is amazing. So depends here. Parents, if you want to paraphrase what your child said, feel free. But if anybody would like to share what they think 7 multiplied by 12 is, what do we think? What do we think? My dear in the back. You think it's 84. Oh my goodness. All right. Does everybody agree with 84? We got a lot of agreement happening. How did you know it was 84? Okay. So let me get this straight. This is a known fact for you. It's a nice one, right? 11. 7 multiplied by 11 is 77, but you said I don't need 11 groups, I need 12. So one more group of 7 gives me 84. Anybody do it a different way? Different? What was your way?
So I did was 7 times 10.
Okay. And okay, so you knew 7 times 10 was 70.
And so I had 2 more groups left. So I would, and 7 plus 7 is 42.
Wow. Anything else? Anything different? Oh, one more? Tell us.
Well, I used a known fact 7 times 6 did recently, and then I just doubled 6.
So you said if we already knew 7 times 6 was 42. Another 7 times 6 would be 42, and together would be 84. Amazing. That is the kind of thinking that we love to see in the classroom. And to be honest, we have some milestones that we cover in our curriculum in terms of knowing certain facts or being able to evaluate certain facts by certain grades. So grade 3, we're saying 7 times 7, and then 9 times 9 in grade 4. But if kids are able to compose and decompose numbers in these ways, they can go so far beyond so much quicker. And the nice thing is that even though these are mental math strategies, they don't always have to happen in your head. So for example, these are representations of your thinking. I just drew them. But you yourself could do that on paper if you were multiplying something. If you needed to figure something out, you could draw yourself an open array. You could draw yourself an open number line, and you could show your thinking that way as well. So we often think of mental math as strictly in our head, but sometimes it doesn't hurt to write it down so we can record those numbers for ourselves. This is the kind of thing that we love to see. We see kids thinking, we see kids communicating, and we really see their confidence grow and that ability for them to transfer that into so many other things, because we know that sense of number in particular spans so many other areas of mathematics in daily life. Thank you so much. Does anybody have any questions about this, about number talks specifically? Nobody? All right, well, we do have a few more minutes, 4 to be exact, before our next session. If you would like to play a little math game, there are some decks of cards at the back. It can be done relatively quickly. The instructions are on the side, a little multiplication mayhem, where you would deal out the deck of cards evenly. Every player holds theirs. Flip over 2 cards. Find your product. Multiply your 2 cards together. And then the person with the higher product keeps all the cards. So if you'd like to spend a few minutes doing that, you're welcome to. Or you're welcome to stay and ask any questions before we move on to our next session. Yes, of course.
You went from 1 digit to double digit for multiplication.
I did.
Are they using this for double digits or double into triple digits?
Yes, we do have kids do that. When we think of what we are used to, which was one of our standard algorithms of multiplying, introducing these beforehand really also helps kids to understand why those algorithms work. So those algorithms were created at a time where there were no calculators. Everybody needed to have the same answer, the exact same way, right, for efficiency. But they actually involve so much complex mathematics, and when we ask kids to do that, they're more memorizing a process than actually doing double-digit multiplication. So showing them this way, they can see how this is split up and relate it to how that works, right? So even if I moved to something greater, I could break apart these numbers. I could show it in an open array and see where the parts of this are in here to really understand that process. Yeah. But I have seen kids use this, and if we want to talk efficiency in terms of being quick, be just as quick as adults who can do it this way.
One more question.
Sure.
Like when you're doing from 12 by 7 multiplied by 12,
Mhm.
it takes a little bit less time multiplying by 17 by 12.
Yep.
If you're looking at time, do you really encourage calculators?
I think there are skills that are encouraged with calculators, but I think if we're asking children to learn certain computations, then those are things that we're encouraging them to understand. So calculators have their place depending on what we're doing, but we do have sometimes where we are strictly evaluating whether or not a child can perform certain mathematical operations without.
And once a child starts using calculators, do they forget the mental part?
I give you my opinion here, strictly my opinion. From my experience with these, I would say children who have become very comfortable in knowing their numbers, knowing how they work, will not refer back to the calculator once they're able to do this. It's been my experience because they're so comfortable in doing it themselves. Yep, and that's something we talk about, right? If kids are going to go to the grocery store, and or as adults, and we're going to calculate something, we're not going to pull out a pencil and paper and do a standard algorithm. We're either going to use a calculator or we're going to do some mental math. And so I really see kids using this over that. You're welcome.
Which grade you introduce calculator grade?
I would think different grades will introduce them at different times. It really depends on what it is they're practicing. Yeah, it might be in primary if they're talking about number patterns, but it really all depends. Yeah. We do have to move to our next session, but thank you so much. I hope you enjoy the rest of your day. Give yourselves applause as well.